All right, welcome back to Parking Lot Part 2. We've been working with object arrays, and we're trying to demonstrate this idea of an object array using a parking lot. So this is our end goal, to end up with something like this. You'll see that I have a constructor here where I designated there's going to be 20 total spaces spread out over 4 rows. And really, my parking lot constructor does a lot of heavy lifting here, right? It just based on that data alone, it basically determines how many spaces belong in a row somewhat evenly. We're also going to label those spaces, right? Everything on this row is labeled with an A, whereas everything on this row is labeled with a B, so on and so forth. And this is going to be pretty dynamic. Also, we're labeling some or indicating that some spots are accessible spots for people with disabilities, whereas these are just generic spots. But here we see the initial state of my parking lot after calling the constructor, right? And then I'm going to take that parking lot and occupy the spot B03. We see that B03 initially has nothing there, but is occupied after I call it because I'm printing it off to see that change. Okay, again, this is going to be dynamic, so if I went to, let's change this a little bit. Let's do like 100 spaces spread out over 4 rows. We're going to see that we get our numbers adjusted accordingly. And again, the first 2 out of each row are accessible spots. If I change the number of rows to say 5, we're going to see that change as well. And again, it's dynamic. It's going to adjust and kind of figure everything out itself. Kind of cool. What we did in part 1 was develop the parking space class. Right? This is the one that we did. You'll notice that my toString is drastically different from our end result. That's okay. We kind of used it for testing. All we really did here was make the parking space constructor. This is a single parking space. Keep in mind that my parking lot is lots of these objects stored in an array ultimately. Okay, so we're going to get started on the parking lot class, and I'm going to preface this by saying this is going to be the hardest part of the entire project. If I was given this project, I might just give you the constructor and I might just give you the toString flat out. If you saw this as an FRQ on the AP exam, you would likely be writing other methods, which we're going to do in part 3. They would do the same thing. They would give you the constructor, they would give you the toString so that you don't have to worry about them because they're complicated. I'm not going to lie to you. I am going to walk you through it, however, and we're going to start by right-clicking on our SRC and making a new Java class we're calling ParkingLot. I'm going to pull this bad boy over so I can reference code if I need to. But starting out, our parking lot is going to have some instance variables. We're going to have, most importantly, a parking space array. This is the object array. This is the whole thing that we're really trying to practice here. This is an array, as denoted by these brackets, but it's not an int, it's not a double, it's not a string. This array can hold parking spaces. Okay. In our last video, mouse, I guess 2 videos ago, we made a mouse array, but we didn't do it as an instance variable, so we're adding even more new concepts here. I'm creating a parking space array, and it is an instance variable, which means it exists inside of the parking lot. Okay. I'm also going to go ahead and create an integer to store my number of rows. Ultimately, I need that data later when we go to the toString. Right? Initially, I can use rows to kind of figure out the layout of my parking lot, give all the labels, that sort of thing. But later on, when I get down to my toString, I have no reference to the rows, and that's ultimately what the purpose of the instance variable is. Right? So I say all that to say that I may or may not write a getter for this. I definitely don't need a setter. This is just data that needs to be stored here so I can basically perform operations later. Let's get started with our parking lot constructor. So public parking lot. Okay, this is going to take in a number of spaces, as you saw with my call to the constructor, in a number of rows. And from that data, just those 2 integers, I can figure out everything else. Let's Java doc this so that we're kind of on the same page. This constructs a parking lot with an equal number of parking spaces. Notice that we're referring to the object there, per row. Now, there's a bit of an asterisk with this. I looked at different ways to kind of evenly distribute it, and we'll kind of talk about it. Maybe I'll show you kind of an example. I'm going to pull back over my completed project. You'll see what I mean. Let's say that we want to do 100 parking spaces, but I want to do 3 rows. What's the problem with that, right? Think about that for a moment. Equal distribution means that I'm going to have an extra little parking spot left over. And you'll notice what I decided to do is just drop it, right? If I just did, 33 per row, I would end up with 1 extra parking spot just on the next row. And what I've decided to do is I'll just drop it. There's ways that you could handle it. None of them were that clean, and ultimately it's just not worth it. What we're trying to do is just practice object arrays, right? Getting into the math of how do I handle the spare parking space is just not worth it. However, we're going to have some preconditions with this, right? In order for this to not fall apart, I'm going to say that spaces is greater than 0. Right? It'd be awkward to try to create a parking lot with 0 spaces or negative spaces, right? Because we're taking in an integer, spaces could be any positive or negative integer value. And so I need to basically make sure that we got something that kind of makes sense. Okay, in a similar manner, our number of rows needs to be positive. It also needs to be less than or equal to our spaces, right? If I say I'm going to have 10 spaces, I can have 10 rows, that's effectively 1 per, but I can't have 10 spaces and 11 rows. That just doesn't make sense. It doesn't work out. So I'm going to precondition it here so that I, as a programmer, don't have to basically check that. We're going to do a post condition. These are kind of rare, for us at least. But we're going to say that parking spaces are not occupied. All I'm really saying is that initially the parking lot is empty. None of the spots are occupied. That's it. Parking spaces. And lastly, the first 2 parking spaces in each row are accessible. Oh, I'm staring at it and I still can't see it. There it is. All right, let's get started with this. So we've declared this array. The variable exists. It is inside of the class. It has this access modifier, so it is an instance variable. However, it has not been initialized. Before I can put any parking spaces in this array, I'm going to need to initialize it. So the first thing I'm going to do is take our lot and set it equal to a new parking space array. Now, we need a length here. Ultimately, my length is just going to be based on number of spaces. Another thing I want to do while I'm here is go ahead and initialize our rows. That is, save the value that's coming in into the instance variable. So I'm going to set this dot rows to rows. Okay. So now this variable, now rows has a value, right? The instance variable has a value. Our our parking space array has been initialized. It actually has an array object backing it with spaces, number of spaces. We're ready to actually start populating this thing. And so the gist of it is we're going to go through the array. So I'm going to create this loop, and we'll say as long as I is less than, you could just simply say spaces. You could also say lot.length, which I kind of like, right? Those are the same value. I just used spaces to set my length of my lot. However, I really want to clearly indicate that I'm looping through the array, right? That I ultimately corresponds to an index in the array, and I think this does a better job of explaining that. Effectively, what we're doing with each iteration is I'm going to initialize these individual elements. The entire array, lot, is a parking space array. each individual element is a parking space. So lot is an array. A single element out of lot is a parking space. In a lot of ways, this is just a parking space variable that is pointing to null currently. I need to basically tell it to point to something else. I need to tell it to point to a new parking space object. Okay, I'm going to throw in some dummy values real fast, and then we'll kind of see what's happening so far. But what I'm going to do with each iteration is set the individual element to be a new parking space object. So notice here I'm calling a constructor. I'm going to call one of these constructors. Right? I'm just going to throw in some dummy values. We'll do like A01, and we'll just say like what, true, false. Real quick, I kind of want to see what we got so far. So we're going to take a shortcut here. We're going to jump down to our toString. And all I'm going to do in this particular case is loop through, print off all the objects, or I'm going to take a super shortcut here and use the arrays class to print off my array. So I'm going to do arrays.toString. I've talked about this in other videos, but ultimately the arrays class, it's a static utility class, right? I need to import it. That's what's wrong here. If I scroll over it, I can hit Alt-Enter, and the first suggestion is import class. I'm going to say that again. I can hover over the red text, hit Alt-Enter. The first suggestion is to import. And so that imported the arrays class for me. Okay. Recall that when we're working with arrays, if I just tried to print the array, right? If I just returned lot or lots.toString, I'm just going to get the hexadecimal location in RAM. Like, I'm not going to get the contents of the array. So in years prior, we would write the actual toString method ourselves, where we would loop through and actually print the individual objects. Well, as it turns out, there's a utility class called arrays. It's static. Notice I did not make an arrays object, right? So I'm just referring to this method statically. IntelliJ is also telling me it's static because it's italicized. But I'm going to call this, that's going to basically do the toString for us and show us the contents of it, which is what we ultimately want. I'm going to flip over to my driver, and I'm going to make a parking lot real fast. So I'm going to create a parking lot. I'm going to call it my lot, and that is a new parking lot. Now this needs some values. Why don't we do something like 10 spaces spread out over 2 rows. Right now, the formatting on this is just kind of not there. It's just not existent. What I'm really showing you is that we're going to initialize these things with new parking lots. I'm going to print off my lot, which is going to call the toString, which is going to call arrays.toString on the parking space array, and we'll see the contents of the array. We'll see what's in there now. Okay. Importantly, there's 10 elements here. And you'll also notice that we've got a bit of content here, right? Our A01, X. What I'm really getting at here is, how does it know to show you this stuff? Right? How does it know in ParkingLot to show me the label of the parking space, if it is accessible or not, and if it's occupied or not? Well, ultimately, that's because we told it to in a way. Whenever we call arrays.toString, it's looping through. It's looping through and creating a toString consisting of each individual element. Well, whenever we access that element, what it's calling then is the toString for parking space. Right? This content is showing up for each individual parking space, ultimately because of the toString that we wrote. Simply put, arrays.toString is calling the toString of the individual elements within our parking space array, lot. And that's why this content is showing up. So this is super nice for testing. So what we're seeing is we have a length of 10. Okay, so that's being initialized correctly. We're also filling it with these kind of dummy parking spaces. If I didn't do this, what do you think would show up here? If I did not loop through and initialize the individual parking spaces with new parking space objects, what would happen here? Well, I'm going to comment this out, so keep in mind it's basically not there. It's as if I deleted it. And you see that it's filled with nulls, right? Ultimately, this is an object array. So whenever I initialize it here on line 24, the individual spots are all pointing at null. It's up to me to go through and tell those spots to point to something else. In this case, new parking space objects. All right, I'm going to bring that back. And we're going to get into the meat of this constructor, because what I need to do is give them not dummy values, but correct labels. I also need to identify the first two as accessible, that sort of thing. So here we go. What I ultimately want to do is cycle through my alphabet whenever we're coming up with these letters. I want to start with A, sure, on the first row, but then I want to go to B, and then I want to go to C. There's no natural way to sequence that, the same way that I could just do 0, 1, 2, 3. Right? So I need to kind of make that sequence. One way to go about this is you could create like a string array with your ABCs. Right? I could say that this is a new string array with A and then B. I want you to kind of notice that these are ultimately going to be individual characters. Meaning you could also do a char array if you wanted. Right? So that looks something like, it's actually easier to delete all that and type it again. It looks like A, B, C, right? This is the same thing, it's just a char array instead of a string array. What I hope that you'll ultimately kind of recognize is, since they're just individual characters anyway, we don't need an array at all here. I could create a string called ABC. And what we're going to do is fill it with every letter of the alphabet. A, B, C, D. So this is all 26 letters of the alphabet. Right? I should probably also say that rows is less than or equal to 26. Here we go. Okay, I don't want to go into double lettered rows, so we'll say that rows is within the range of 26. Okay. So I have the string with all my letters of the alphabet. This, in a lot of ways, is a character array, right? Because we have individual elements, A, B, C, D, E, and they're actually associated with an index, 0, 1, 2, 3. So what I have established is a natural sequence, right? Using integers, 0, 1, 2, 3, I can basically progress through this string and simultaneously progress with my labeling on the rows, right? We're going to start at A and then move on to B, etc. You could have used a string array, you could have used a char array, but recognizing that a string basically is an array, and if we only need one character, we can get away with just using a string, which is going to be a little bit cleaner here. Easier? No, that's debatable, but cleaner for sure. Okay, so this is my natural sequence. So let's kind of set up our lettering, and this is kind of what's difficult. With each iteration, I'm going to basically create a parking space. Well, I need to assign it a letter. Right? So I'm going to create a char, which I'm calling letter. And ultimately, the char is going to come from this ABC string, but I need to know which one. Right? I have a certain number of spaces, and I want to spread them out over the rows. So one thing I need to do is figure out how many spaces am I going to have in a single row. Let's kind of create that value. So I'm going to create an integer called literally spaces per row. And it is number of spaces divided by number of rows. And this is where that awkward math stuff was coming in that I was talking about, right? Let's consider that spaces is 100. Right, let's set up a test case where we're talking, we're going to call parking lot, and we're going to pass in 104. Well, this math is easy. We got 100 divided by 4. That is an even 25, so spaces per row is 25. But what if this is just simply 3? Okay, well, we're going to do 100 divided by 3, which is going to be 33.333 and some change. Right? So truncation will occur whenever that happens, and that particular number would, truncate down to just 33. And what I'm saying is, let's just roll with it. It's just not a big deal. It's going to make some minute changes, which we just won't even pay attention to. But now that I know how many spaces are per row, I basically want to figure out my character based on that. So as long as we're on the first row, I need to basically pull out this character, the character at index 0. So 0 is the mathematical thing I need to get to, right? I know what parking spot I'm currently on. It's the value of I. Really, it's kind of the value of I plus 1, because I don't necessarily want to start the numbering of my spots at 0. I want to start them at 1. But the way this math ends up working out is if I take my current spot and I divide it by the number of spaces per row. Okay, so let's think about this. Initially, my very first spot is 0. I'm going to do 0 divided by, in this case, we'll say 33, right? If I do parking lot 100, comma 3, why don't we, let's keep going with this. If I do 100 divided by 3, really my spaces per row is going to be 33, okay? So if I am on space 0, the very first space, and I divide that by 33, what am I going to get? Some fractional part which is going to truncate to just simply 0. That is my index. Let's say that we advance a little bit and then we get to spot 34. I'm at spot 34 divided by 33. That's going to be 1 point something. Because we're going to have truncation occur, that's going to truncate to just 1, which is going to give me my next index. So you see that as soon as I eclipse that 33 mark, we're effectively increasing our index. So this is the index. What I've highlighted is the index, and I need to actually pull the character from the string here. So I'm going to take my string, which is ABC, and we're going to pull the character at I divided by spaces per row. In CSP, I get the constant question of why is truncation even a thing? Why do we want it? It's actually super useful here. I'm using it to, in a lot of ways, kind of wrap around to the next row. So this is how we're going to select our letter. I can pass that into my parking space, right? Instead of using the version that takes a string, I can call the version of parking space. It takes a letter and a number. So let's pass in that letter. And we'll give it a dummy number for now, although the number is super easy. I'm going to run it. And there we go. I think, yep, see, so I did, what are we doing currently? 10 and 2, why don't I update this little comment to kind of reflect that. If I do 10 and 2, number of spaces per row, number lock's not on, number of spaces per row is going to be 5. Right? I have 10 total spaces. After the first 5, we did A, and now we're on B. Okay, so our lettering actually looks pretty good. We just need to come up with the space, or the numbering now. And what's awkward or different about the numbers is, well, I kind of have the spot number. So it's kind of easy just to plug in I. Let's take a look at what's going to happen there. For starters, I hope you see that the very first spot is 0, 0, and then 0, 1. I need to shift those. So I don't exactly want I kind of just want I plus 1. Now, just like with our lettering, I actually need the number to reset for each row. Right? We see that the numbering, this looks pretty good, particularly for the what would be the first row. But when I get to the next row, I need it to effectively reset. Now you don't want to like edit I, right? Because I is ultimately controlling our index for where we're inserting parking spaces. What I will consider doing is creating some type of variable, and then we'll do the math here before sending it to the constructor. So what I'm going to do here is kind of something similar. I need to know after how often do I need to basically reset this. And as it turns out, modulus is going to help us here. I know I did a terrible job of explaining what we want, but I'm going to do I mod spaces per row. Let's think about this for a moment. Let's say that our spaces, let's use our 10 and 2 example, right? So let's say that we're on space 2. I'm going to do 2 mod 5. Okay, what is 2 mod 5? Well, if you don't know, let's just let's just plug it in here and find out what it is. 2 mod 5. Okay, that gives me 2. So when it's just the number itself, when you have a number that is less than what you're modding, you're basically going to get the number itself, right? 4 mod 5 is going to give me back a 4. We're going to ask, how many times does 4 go into 5? Sorry, let me rephrase that. How many times does 5 go into 4? 0 times, and you have a remainder of 4 left over. That's where this number is coming from. Now, once I get above this, let's say that we're on spot 9. What is 9 mod 5? Well, that's going to be 4 as well. And so using mod, we can actually kind of reset our numbering. So I'm going to plug in this number right here that we are figuring out on this row. It's going to have a slight problem, and we'll just immediately fix that. So take a look at my row, right? Starting out at 0, 0, that's the slight problem. But we got 1, 2, 3, 4, ooh, and then it resets. And that's the important part, and that is due to mod. What I need to do is basically just shift that by 1, right? I want my initial spot to be 1, and then 2, 3, 4, 5, and then go back to 1. And so just by simply adding 1 there, we can cause that shift. And there is our labeling. Okay, I'm going to take out this simple little mod equation. So we're getting our labels. We're putting in dummy values for occupied and false. Simply put, I don't want them to be occupied, so I'm going to change that to a false value. Now, the accessibility is something we're going to have to figure out. I want the first 2 per each row to be considered accessible. Okay, so I'm going to create a Boolean value, which I'm going to call accessible. And we need to figure out what should it be initially. So we could simply say that we assume it's false. However, we perform a check. How do we know? I want the first 2 per row. So I want these 2 spots. And then I want these 2 spots. Well, it turns out we did all the heavy lifting already. And this is actually super easy relative. Okay, what do I mean? Take a look at what these 2 spots have in common compared to these 2 spots. Right? It's the numbering. I'm actually calculating this number already, so I can just use it. If our number is less than or equal to 2, then we're going to consider the spot to be accessible. I am aware that I butchered this yet again up here. We're going to set accessible to true. So regardless of what the value is, whenever I reach this point, we've either determined that it's an accessible spot or it's not. Instead of passing in a raw true or false value, I'm going to pass in the variable, which is going to tell me should it be an accessible spot. Okay, and there we have it. Those first 2 spots in each row is accessible. So I'm going to double check my constructor. We may be done with it. And yeah. Okay. I'm pretty happy with the constructor at this point because it is doing the stuff that I want it to do. We're saving in our rows. We're initializing our parking space object array. We need to determine how many spaces per row there are. That helps us with our calculations later, right? I end up using that here and here. we have this string array to help us with our lettering sequence. We're going to loop through our entire parking lot. We're going to figure out what letter it should be by pulling it from our string. We're going to figure out what number it should be by just simply basing it on the parking spot that I'm currently on, I. Here we need to figure out if it's accessible, and I'd like you to actually kind of notice that we need a true or false value, right? Initially I assume it's false, I then do this check and then change it to true. However, this is actually giving me a true or false value. So I can clean this up. I could put it just simply here. Realities are I don't need the variable at all. I'm getting a true or false value thanks to this. Simply put, we could just pass that in. Here at the constructor, instead of using that variable, I'm just going to decide on the spot, is num less than or equal to 2? Okay, this would produce a true value if that is true, and that's what we would pass into the constructor. If it's not, we're going to get a false value, and that's what gets passed into the constructor. So I'm going to delete this variable, run it again, and we'll see that we get effectively the exact same thing. Right now, our toString is just calling the toString for each of the parking spaces, right? That is the toString that we wrote here. And that's perfectly fine for our testing. What I am able to test is that our constructor works, and let's actually up the count here. Let's do something like, what about 20, but do something like 3 rows. Okay, so there's my A's. There's my B's. There's my C's, and you see that we're going to get some D's. I'm okay with them existing. Really, I'm just okay with this. Ultimately, we're going to come back in our next video and write the toString with maybe some other stuff, maybe the rest of the project. But this has been the constructor, and it's been a lot because I'm looking at my time, and we're at 30 minutes. So we're going to wrap up there. I'll leave this on the screen, and I'll see you in the next one.